All right, so today is Glazing 101. Again, like most of these trainings, this was kind of extra designed for like a brand new person. So hoping obviously this is primarily should be just a refresher for all you guys, but we're gonna do two more of these. There should be a 201 and 301 where we'll get into a little bit more advanced stuff that should be able to help everyone out. So we're just gonna kind of go through kind of what Walters and Wolff is, how the projects start, what role each person we deal with kind of in the project has, and just kind of some basics on, glass types and systems, general high-level overviews, and then some design stuff at the end. So, can you guys see the presentation?
Yep.
All right, so Glazing 101. So welcome to Walters and Wolff. We design, manufacture, and install exterior window and cladding systems. The primary materials that we use are aluminum, glass, and stainless steel. We are a continuous improvement company, and a key component of our business model is building and maintaining relationships with our business partners. So Randy Wolff and John Walters established the company in August of 1977. Randy and John previously worked at a company called Heart Glass, which they then purchased 2 years after they started Walters and Wolff in 1979 to expand and grow the Walters and Wolff business. So that's one of my favorite Randy stories. I think it's pretty awesome that he just took that place over. General project types. There are all kinds of different types of construction projects. There's commercial versus residential, public versus private, office buildings, condos, mixed-use buildings, schools, hospitals, etc. Each different type of project has its own set of characteristics. So we at Walters work almost exclusively on commercial projects, so we aren't going to be able to get new windows for your friends and family. Private projects means that the project is funded by an individual or a corporation. Public projects mean that the project is funded by the government, so that's either the state of California for us or federal. Our specialty here is commercial office buildings that are privately funded, but we do some mixed use, some educational, and some public work as well. Condos and hospitals are a four-letter word around here, so we do not like to do condos and hospitals. Condos almost always end up in litigations and lawsuits. And hospitals are super intense and scrutinized and take forever to build, and they end up utilizing a lot of our resources for a long period of time just to get one building done. So first thing, just wanted to cover owners and developers and what their role is. So the first thing that happens on a project is an owner or developer decides they want to build a building. Owners can be individuals or corporations, and they are obviously responsible for all the financial obligations of the project. Some of our key customers on the development side are John Arriaga, Jay Paul, and John Sobrato. We also do a fair amount of work for Alexandria Real Estate, ARE. When the developer is a corporation, they have an owner's rep to sign to the project. So the amount of hands-on involvement from the owner or their rep varies from project to project. So sometimes we're kind of shielded from the owner, like the owner will meet with the architect and the contractor, and most of our interactions are with the GC. Occasionally, specifically for some of that Arriaga and Sobrato stuff, because they have such a close relationship with Randy Wolff, they'll just come on site and we'll just do whatever either one of the Johns says for the most part. Architects are hired by the owner, and they represent the owner's interests throughout the life of the project. Architects work with the owner to design the building and then to achieve the owner's desired look and function of the building. So they create the drawings and the specs for the project. These drawings are broken up into different sections: architectural, structural, mechanical, electrical, etc. So the way I kind of look at it is architects are kind of like C+, B- students for everything. Like they need to be able to walk into a room and have a relatively intelligent conversation with us about curtain wall, and do the same with the stud guy and the plumber and the electrician and whoever else. When we go on site, like we need you to be an A+ glass and curtain wall guy. Like we need to be the smartest person in the room when it comes to the curtain wall and window systems. So general contractors work for the owner and their contract is with the owner. We provide pricing to the GC and then our contract is with the GC. On private projects, the owner and the GC decide how they want to bid the project, and it can either be negotiated or hard bid. So a hard bid just means that they send the drawings out to 2, 3, 4, however many different glazing subcontractors, and then it's like low man wins. If it's negotiated, then that means that the GC or the owner or both decided that they'd like to partner with us on the project, and then our sales team provides budget pricing and works with the general and the owner to hit the budget and justify and explain our numbers and let them know that it's a fair market rate and all that stuff. So as a project manager, it's very important for you to understand the context of how this project was priced and awarded to us. So if it was hard bid with some random GC, then yeah, we should go charging after every change order and make sure we get every dollar that we can. Because we're such a relationship-driven company, you know, we have projects right now that we're working on that we were originally like $1 million high, and the GC or the owner is like, hey, you guys need to, we want to work with you, but you need to tune some things up. Or they just straight up give us the work to begin with. So we don't want to upset or tip over the apple cart, so to speak, over, you know, pennies. And a lot of the projects we like to work on also are multi-building campuses. So we want to continue to get phase 2 and phase 3 of those projects. We need to really perform and keep things moving on the front end when we're involved on phase 1. So for the GCs, DevCon and Level 10 are our 2 biggest customers. We also do a lot of work for Arriaga, who partners up with Vance Brown, Sobrato Incorporated. South Bay is a pretty high maintenance GC, but they pretty much give us all of their work. So they rely on us pretty heavily. So it's a pain, but it's worth it. And we kind of know that going into it. And Hathaway Dinwiddie is another pretty good customer of ours. And then other GCs we work with are Pankow, DPR, Rudolph and Sletton, Turner, and Trubeck. So our sales department, so the GCs contact our sales department and ask us to work on projects with them. Sometimes this process can take a year or more, and they will, depending on how the job's being priced, sometimes GCs are like us, they need to competitively bid the project. So, you know, you might have 3 GCs chasing the same job, and they'll ask, you know, they'll partner with us and the other guy's partnering with a different glazing contractor. So our sales team will give them sometimes budget numbers as the drawings are being developed by the architect. And then once the drawings are far enough along, then our sales team will review everything with our field crew and our jumpstart team. So at this point, they'll decide what window systems we're going to use, and then they'll price the job accordingly. Once the contract drawings are developed enough to be priced, then our sales team submits a proposal. So this is one of the main reasons why we like doing privately funded jobs, because when it's private, our proposal includes our scope inclusions, our exclusions, and our qualifications. So our inclusions is basically everything that's included in our number, but then it's also any wonky stuff that we do not want to do. So we can say, hey, we're not doing this, we're not doing that, you know, and then a qualification can be like, strike this out of the specs, or we're not, you know, this doesn't really work. So it's our way of explaining, trying to explain very clearly what's in and what's out of our number. On public jobs, they usually come with a scope letter or instructions to bidders. And then that tells our sales department what to include in our price. So then we are obligated to cover that scope in its entirety without exclusions or qualifications. So this used to be, it used to be kind of called like a plans and specs type of thing. And because it was taxpayer money, they had to have 3 bids, and it was always a low man wins type of thing. In the Bay Area, when the economy is doing well, what was happening is people like us, and some of the other, high performing subcontractors just didn't want to get bogged down doing a lot of public work. So they were not getting 3 bids, and they were getting kind of a bunch of bottom feeders and things like that. So occasionally, kind of like Candace's job right now, Natural Resources, and Blake's job, O Street, both of those projects are public, but the GC and the state agreed to negotiate those projects with us. So it's kind of a 50-50 thing on that from time to time. So just some real basic stuff on glass types. Vision glass is obviously glass that you can see through when you're looking out your window. Vision glass can be clear, it can be blue, green, gray, like there's any number of colors that can be used to have vision glass. Even if it's clear glass, it will have trace amounts of iron in it. So I think there's like, 91% clear, which is why when you hold a white piece of paper up behind a piece of clear glass, it tends to have a greenish hue to it. So there is a kind of a specialty premium glass type known as low iron, where the glass manufacturers try to extract the iron and reduce the amount of iron in the glass to get it super clear. Spandrel glass just means that you can't see through it. So kind of up here in the left corner, this is a detail from our shop drawings. We kind of are illustrating that there's a ceramic frit or a coating that gets applied onto typically the number 4 surface of an insulated glass unit that prevents anyone from being able to see through the glass from the exterior. So monolithic glass just means it's a single pane, single ply, single piece of glass. We'll do that occasionally for, not anymore on handrails, but that's primarily now an interior only. Due to Title 24 and energy codes, almost everything we do now is a dual pane or an insulated glass unit, referred to as an IGU. So typical IGU is a 1/4 inch piece of glass, and then there's a 1/2 inch aluminum air spacer, and then another 1/4 inch piece of glass. So that's all kind of sandwiched together and then sealed around the perimeter to create that 1 inch IGU. And then we refer to the surfaces as the front and back of each piece of glass. So the exterior surface is number 1. Inside the IGU, which you can't touch, is number 2. And then you also can't touch number 3. And then the back side of the glass is number 4. So there's different types of coatings, whether it's a high performance low E coating or spandrel coatings that can be put on the 2, 3, or 4 surface. And we'll need to note that when we're placing glass orders. Laminated glass is similar to an IGU in that it starts out with 2 different pieces of glass that get sandwiched together, typically over either a PVB, a polyvinyl butyl inner layer, or an SGP, it's a Century Glass something, Century Glass product maybe, which is just a stronger, more durable inner layer. So typically laminated glass is required in kind of super sensitive safety areas. So that would be any overhead glazing, like a skylight, or even a canopy, like when you walk out of a building. So if that glass ever breaks, you don't want the shards and the piece of glass to fall on any random person walking underneath it. So that PVB or that SGP inner layer, in the event the glass breaks, it holds the cracked pieces of glass in place temporarily until it can be swapped out to kind of keep everyone safe. We also occasionally do mirrors, and then there is fire rated glass. which we can purchase from fire-rated glass suppliers. And then very occasionally we'll get into bullet-resistant glass, usually on like stadiums or concert halls if there's like a ticket window or something like that, which is usually just multiple pieces of glass laminated together with like 4, 5, 6, 7 different PVB or SGP inner layers. And there's a new glass type on the market the last few years, kind of known as electrochromatic glass. We've used view glass 2 or 3 times and halio glass once so far. This picture over here, right in this kind of corner, this is all the same glass. It's all vision glass, and it's this electrochromatic glass. So electrochromatic means that the glass can be programmed and you can change the tint of the glass manually to make the glass either darker or lighter, so that can help. It can help when the sun rises at a certain elevation. It can make the glass a little bit darker, and it helps lower the amount of heating and cooling needed inside the building. So it helps drive down your HVAC costs. It can be a challenge for us because it's electric and there's wires, and we have to fish all that through our window system, and it's a relatively new product in the market. So there's liability concerns and warranty concerns and things of that nature, but we'll walk you through all that if and when you get an electrochromatic glass job. So glass manufacturing, float glass is made literally by like melting sand. They get it up to like 1700 degrees Celsius, and then they add like ash and limestone and particles of recycled glass and kind of turn it into like liquid sand, liquid glass, and then let it cure. So at that point, that's where the clear glass or blue or crystal gray or the actual raw glass is made in giant factories. They call the big sheets, big pieces of glass they make, are stoche sheets. When glass is made in its original raw state, it is annealed. We'll cover what that means on the next slide. So we at Walters & Wolff, we do not ever purchase glass directly from the manufacturer. And then just some of the names of the big manufacturers that we deal with are PPG, Guardian, and Pilkington. And those are usually listed in the specs. So for us, we deal with glass fabricators. So the glass fabricators, or we call them vendors, actually, they're the ones that buy the glass from the manufacturer. And then we give them, a glass order form, kind of like shown down here, that says exactly what the glass makeup is, whether it's laminated, an insulated unit, what color glass, what coatings, etc. And then we'll give them, the quantity of lights that we want with the exact sizes, and also usually a distribution or a delivery schedule. So then we give that to the fabricator. They figure out how many large sheets they need from the manufacturer. They buy the glass from the manufacturer and then cut everything to size, create the IGUs and the laminated glass, and then ship it to us when we need it. So like I said earlier, when glass is originally made, it's annealed. So what that means is that if you were to like throw a rock or try to punch your hand through a piece of annealed glass, this top picture up here in the left corner, this is what happens when it breaks. You get a little hole in the middle and you get these big giant shards, which if you did put your hand through that and then you tried to pull it back, pretty good chance you can slice your wrist, cut yourself. It's not very safe at all. So there are safety codes and things we need to be aware of, and certain locations on the building where safety glass is designated as being required there. So when that happens, we can temper the glass. Laminated glass is also considered safety glass. But the difference between annealed and tempered is tempered. What the fabricators do is they take that piece of glass, cut it to size, and then they put it in an oven or a furnace, and they heat the glass up really quick and they cool it down really quick. And that causes some chemical reaction and stress and tension of the glass. It makes the glass stronger. So one, it's less likely to break in the first place. but two, if it did break, it would shatter pretty instantly into a whole bunch of little pieces. So have an example of this with Shaquille O'Neal down here in the corner. So all the glass falls on him, but there's no shards. There's nothing that's gonna, you know, puncture him and cause any serious damage. So the primary glass fabricators that we use are Viracon, who's located in Owatonna, Minnesota, and then Glass Fab's our local supplier there in Tracy, California. Other products that we use are 1/8" aluminum panels. So we can do 1/8" solid plate panels, where it's a solid sheet of aluminum, and then it gets cut to size, formed, and welded with ground smooth corners, and then painted. Our two primary panel suppliers are Pole in Utah and Americlad / Quality Metalcraft. I think they're in Minnesota also. A different type of aluminum panel that we use are composite panels. And that's just two thin layers of aluminum on the front and the back. And there's a coil coat paint process that goes along with that. So we'll buy those sheets from the supplier, and one of our main ones is Mitsubishi. And then we have two big machines, one at each of Shop A and Shop B, where we can cut, notch, route, and groove the back of the panels and fold those up. And create the panels ourselves at our own shop. Both of these panel types can be installed loose in the field if you had like a big panel wall, or they can also be made to be placed into our curtain wall units in the shop. There's other descriptions for various, you know, ways to install panels or different purposes that the panels serve. There's a shadow box panel, which is behind a piece of glass, or a back pan to kind of trim out the back of the window system opening on the interior. We also do perforated panels, corrugated panels, and then regular glazing panels. An operable window is just a actual window that opens. We don't make those ourselves, but we do buy those. Our pretty much our main supplier, I would say, is Wausau Windows for that. A louver is a vent, and that's where the kind of heating and cooling is all the mechanical equipment of a building is running. They need to kick out air to the exterior, and the way to do that is to go through a louver. So if it's a steel louver, we won't do it, but if it's a louver they want us to do, then we can get an aluminum louver, which again can be standalone by itself in the field, or it could be glazed into our window system. We also sometimes do skylights. For the most part, we sub that out to companies that specialize in that, the skylight subcontractor, but that would fall in our scope of work. We'll do canopies. You can do a glass canopy. You can make a canopy out of panels. We also do sunshades and baguettes. Occasionally we'll do terracotta and vertical fins. We do stainless steel column covers with stainless steel sill flashings. We do not do galvanized sheet metal flashings. So if you see a GSM or a sheet metal, then that's by some other guy. So occasionally, on very rare occasions, we will get stone in the curtain wall. For the most part, unfortunately, this tends to end up in our precast group's scope of work. Then there's a whole bunch of different doors. We make our own storefront doors, which is a door with a big vision light in the middle with an aluminum frame on it. So we buy all the parts and fabricate everything and build those ourselves. Then we also do glass doors, which we buy out, and everything else here we buy out to fire rated doors, revolving doors, balance doors, and bifolding doors. And then there's also structural glass walls, which again is a buyout system where we'll purchase the materials and outsource the engineering, and then have the materials delivered on site, and our field crew can install them. And our two biggest vendors we use there are Centec and ISG. Just a basic comment or general comment on spandrel. Spandrel just means you can't see through it. So when we're installing a curtain wall, the window system is bypassing the floor line. So the architect usually doesn't want people to see the concrete edge of slab and all the electrical wires and plumbing pipes and things like that. So they have us install a spandrel element to kind of bridge that gap. So it could be spandrel glass, it could be a panel, it could be a shadow box panel, stone, or it could be a GFRC or a precast spandrel panel that just breaks up the window openings above and below the floor line. So window system components, just kind of the basic nuts and bolts of a window system. We try to describe everything that we're doing so that when we're in meetings with internal people or whoever, we can be on the same page and make sure we're talking about the same thing. So typical parts for a window frame are a head, a horizontal, a sill, and then an intermediate mullion or a jamb. So the head is the top of the opening. So like this guy's a head, and then anything in between is a horizontal, and then the bottom of the opening is a sill. So you always have one head and one sill. So like down here, you have a head, and then horizontal, 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 and sill. So then a jamb is the vertical member on the edge of the opening. So for these kind of little punched opening guys, you have a jamb and a jamb. Here you have a jamb and intermediate vert, and these are all intermediate verts. So you have two jambs on this opening with 20 intermediate mullions down here. And then here you have two jambs and no intermediate mullions. When it's a unitized curtain wall, like this opening over here, we'll have a sill, horizontal, and then wherever the units break up, we call that a stack joint. So here it goes, sill, horizontal, stack, horizontal, horizontal, stack, horizontal, horizontal, head. And then if you go to the portal and you go to engineering and then standard system information, if you click on the W75 system and go to the sales catalog, that's where our standard detail library is kept. That's where all these kind of screenshot examples were pulled from. And it's a good way to kind of walk you through the terminology and get you up to speed on what everything is. So if you look closely here, this would be a jamb where it's just got glass coming in one side because again, it's at the end or the edge of the opening. This is an intermediate mullion, which means it's got glass coming in from the left and from the right. And the only difference between these two mullions is this one, we consider this one captured, which means it has an aluminum element that's exposed on the outside, and that's actually helping to hold the glass in place. Versus this one, which is an inviso structural seal type of thing, where there's no aluminum on the outside. So this piece of glass is literally caulked and sealed to the frame, and that's what's holding the glass in place and preventing it from falling out. So then also you'll just end up having all kinds of conversations about different openings and trying to describe things. So I thought it'd be helpful to go through just descriptions of openings. So a curtain wall is a window system that spans multiple floors and it hangs off the edge of the building. So a curtain wall, because it just has to bypass at least one floor line. So a curtain wall can be 2 stories tall, 20 stories tall, 50, 100 stories, doesn't really matter. And you can kind of see over here, like these are we call those mat clips. It's our slab anchor. And so this curtain wall panel or unit is hanging off the edge of the building. So the concrete's actually inside the exterior skin. Another type of opening is a ribbon or a strip window. So basically it's kind of arbitrary, but it's just something that runs a long distance horizontally between the floors and does not span multiple floors. So you can sit on the ground or on a curb or on a pony wall. And again, it's kind of random. It could be 20 foot wide, or it could be a nice long, 100 and something foot and run like we have here. So this is a picture of what it looks like in real life. Here's a section from our shop drawings. It kind of shows it sitting on a little curb right above the floor line, and then it's stopping underneath the soffit. So it's not bypassing the floor up above here. And that's also shown in this elevation here from our shop drawings as well. And the last kind of thing is a punched opening. So it's just a smaller opening It's kind of arbitrary, but it's usually 1 to 3 bays wide, and it sits in between the floors also, and does not span multiple floors. So this was the first Lawson Lane project done by our wonderful Candace Mateo a few years ago, and here's some punched openings over there. Then another type of opening is just the people as storefront opening. So basically when you go to like Chipotle or Subway or a strip mall, all of those would be just considered a storefront opening. So occasionally we'll do a larger building and they'll call sometimes the ground floor stuff storefront. So for Walters and Wolff system types, typically we've gotten a lot better at this now. We follow sales lead on which systems we're using on the project. So there's various factors that go into that decision, such as performance or matching architectural profiles, and sometimes matching other existing buildings. So in general, most of the time you can utilize each system for each different description of an opening. So for example, you can use a W75 to build a curtain wall or a strip window or a punched opening. And the same thing with a Techwall and a CAM system. So for our W75 system, for the Walters and Wolff standard systems, this is our standard unitized system. The system has 2 3/4 inch wide mullions, 2.5 inch tall horizontal members, and it is 7.5 inches deep. So unitized means that we split the window opening up into smaller sized units. Typically they're broken up at each vertical mullion, and most of the time at the floor line if they go that tall. So they usually around 5 foot wide by 13.6 tall. These things will get fabricated, assembled and glazed in the shop. So this is an older picture of shop B, where we're building the frames in kind of an old school assembly line type of format. So for this system, as a PM, most of the materials that we order get designated as shop use because the shop's going to be the people consuming the material and building the units. So all the glass, gaskets, metal, sealant fasteners need to come into the shop. There are other smaller products that will get installed in the field. So we'll buy those and designate those as field use items as well. So once the shop is done, we package the units on large pallets, and we'll normally stack them up to about 6. So we'll call them, we don't want to go taller than 6. We'll call them, 6-packs. And so there's an example of a couple of skids of pallets at a job site. So they opened up 2 or 3 different pallets at this particular area, and then had the mobile crane come in with the suction cup apparatus. And you can see here, you have like some foam and wood blocking to kind of help space in between each unit to keep everything safe and protected in transit from our shop to the job site. And then the unit just goes up on the crane, and then our field crew installs it like that. The other kind of primary system that we use, probably the second most common, is our Techwall system. We call it a Techwall. It's essentially a pressure plate system. Gets fabricated in the shop and then is erected and glazed in the field at the job site. So the system's similar. The whole thing's 2.5 inches wide, both the verticals and the horizontals, and then it's 7 3/4 inch deep. The system's considered pretty flexible from a design point of view, because you can change the way the system looks by simply changing the exterior face cap. So here we had a little skinny extended trim piece that they wanted added here. So you can kind of keep the nuts and bolts of the system the same and change the look. Instead of having a smooth flat cap like that, you can get some depth and a custom profile without adding a lot of cost to your project. And then also, like if you go back to the unitized system, we have male-female parts that kind of mate together because we split everything at the vertical mullions. So that's okay, but it's not super strong. So on the Techwall system, the vertical mullions are a complete hollow tube type of profile. So they're a little beefier and sturdier. So this is like a picture from the SCU project that Eric's working on. So you can see from the ground floor, with the first place we're able to make a connection is, you know, like 18, 20 feet up in the air. So in order for these mullions to handle the various loads that are going to be imposed on it, we end up using the Techwall at this location for those types of reasons. So typically it's used in high span openings, in lobbies, and or on the ground floor. So wanted to go through quick basics of drawings. So in general, everything should be connected. Details and sections and plans should all be connected and tied into each other, so you can figure out where this detail occurs on the project. So everything starts out with the architectural drawings, and then, like I said earlier, they try really hard, but there's going to be mistakes, and there always is, and there's things that need to be cleared up. So we'll use those for pricing, and then we'll give those to our drafting team. But then we'll create our own shop drawings, which kind of does a whole bunch of things. But the primary thing is it's our understanding, and it confirms our scope with the GC and the architect. But then it also is a form of, like, the most important form of communication we have, because it's going to tell us, you know, exactly what we need to fabricate everything, what parts to buy, how it goes together, how to cut everything in the shop, how to put everything together in the field. So here, I have kind of a side-by-side view of just what a plan view is. So plan view, just what it sounds like, you're looking at a floor plan. So this is an architectural floor plan for a project we worked on the left, and then this is our floor plan on the right. So you can't really see too well here, but there's things keyed in here. So there's like a little arrow here pointing to this entire elevation. And so they'll have that on all four sides. This little legend here with the N, that's telling you which elevation's the north, so you can figure out southeast and west off of that. They will key in, you know, they're on architectural drawings, they need to put a bunch of information for a bunch of different trades on one piece of paper. So it doesn't have the amount of information that we need to assemble and cut and install everything. So they'll just put, you know, 30 foot between grids and key in like one section here or one detail at the corner, and that's pretty much it. So on our shop drawings, we're only going to draw our scope. So we're going to try to clean things up by just ignoring elevators and bathrooms and stairwells and all the stuff inside the building that doesn't really affect us, because we don't have anything going on. But then we're going to draw an elevation. Instead of one massive elevation, we'll draw an elevation for each opening, and then we'll key that in on all the floor plans. So just one other general thing for floor plans, whether it's in the architecturals or our shop drawings, is there's always grid lines, and there's always one row of letters and one row of numbers. So this is, so if you're talking to someone on the phone, you can be like, oh, go to grid, you know, B, you know, 5. And then that's how you know you're talking about this, versus B1, which would be up here. So yeah, and then plan view can be floor plans, but it's also just the idea of you're looking down on something. So you can be on a floor plan, but it can also be on a detail. So for us, our standard is to draw all vertical elements, our intermediate mullions and our jams. Whenever it's a plan view, we draw all of those in plan view, like we're looking down on it. Elevations are pretty much what they sound like. It's just like you're standing outside with like your phone or a camera, and you just take a picture. So it shows you what that picture looks like, but it does not do a very good job of representing the depth. Like on this particular opening over here, this kind of big pop-out window on top, this was, you know, 15 feet in front of this wall over here. You can't really tell that when you're looking at this picture. So even on the elevations, they're going to have grid lines there as well, so that when you're looking at the floor plan over here, you can tell, you know, like if this corner is, you know, A, then that's, if A is on the left, then you're looking at up here, or if A was over here, you can kind of navigate your way around the drawings that way. So this is an architectural elevation, which is pretty vague. You can see there's not a lot of details for the window system specifically called out here. So what we'll try to do is take the architectural drawings and then we'll key in our blow up elevations. So this over here on the right, this is a blow up elevation where you can see, okay, this is the sill, this is the horizontal, here's the stack joint detail, here's the jam detail, here's an intermediate mullion detail. And then this opening goes here and this opening goes there. So that's what I mean, how everything's kind of tied together. Then the third kind of basic is the idea of a section. So a section is basically like if you were, sorry about that. Sections are if you were like a ghost and if you could like float through a wall, like what would you see if you turned your head and looked sideways? So in the architectural drawings, they'll do a full building section, which is up here in this top left corner. They'll also do a wall section. And then you can view a detail in section as well. So this detail here is plugged into or keyed into this wall section. This wall section could be keyed into, you know, the architectural elevation right here, and or it could be keyed into the floor plan over here as well. So then for us, on the right side over here, we'll draw our sections where we decide that we need them, but then we'll key in a little bit more information for a sill detail, horizontal, stack joints, soffits, panels, etc. And then again, our details can be viewed in section as well. So for us, our company standard is to draw all horizontal members. So that's sills, horizontals, heads, and stack joints. All of those are always drawn in section view. Then the last thing are just general details. So on the architecturals, again, they're gonna, you know, usually want to show a little bit more, like the entire picture, because it's not just, they're not just for us, they're also for stud framers and, you know, whoever's doing sheetrock or plumbing and electrical and all kinds of other things like that. And so then like there's not usually a whole ton of information on the window system on architectural details. So like here's a sill and there's a couple notes about, you know, all this other stuff happening outside the building. So we don't really care. So we just kind of dash in, you know, landscaping, but then we'll get down to, you know, what size and what call out of every single screw, every single gasket type that we need, how big all the caulk joints are, show our shim stack that's going to be there, along with the glass and the metal framing and parts like that. And so then here's like a kind of an odd panel canopy thing we had. And this is what the architectural detail looked like. And then this is what the detail looked like in our shop drawing package. So real quick, just wanted to go through some design information. Typically, this information is found on the cover sheet of the structural drawings. So that's going to start off with like an S.01 or something like that. And also some of this information can be found in the specifications. So what we're doing here is we're looking for building codes, exposure categories, design criteria, and seismic criteria. So for exposure categories, it can either be like B, C, and D. So most of the projects that we deal with are exposure C. So here's just a picture of San Francisco. And so basically what we're trying to do is like, how exposed is this building to the natural elements? So like this guy right here is pretty exposed. It's the tallest building in its immediate vicinity. So all these other things, all these other buildings are, you know, 2 or 3 stories tall, and this is 15 stories tall. So this is going to get the bulk brunt of the wind. So this would probably be an exposure C. When you have a bunch of buildings that are the same size all near each other, so even though these are taller, doesn't necessarily mean it's going to experience more wind, because some of these perimeter buildings kind of act as a shield. So sometimes you'll get a high-rise building in a downtown area, and it actually goes, the criteria goes down to an exposure B, just because it's protected from the nearby structures. So most of the stuff we do is C, that's fine. Occasionally you'll get a B, also fine. It just means you can get away with slightly less steel reinforcing and a few less screws and things like that. Exposure D is pretty rare, and if you have that, that needs to be something you need to be aware of. So that's going to happen if your building is pretty much like right on the edge of water. So if you got all the wind from the bay or the ocean coming and hitting your building, if they have an unobstructed run, 500 feet or 1,000 feet, something like that, coming at your building, then that building needs to be designed in a way that it can handle those higher loads. And then, so all that stuff's here in the design criteria in the structural drawings. So exposure category C, the importance factor of 1, it's got various wind speeds, it's referencing, this is an older job, CBC code 2013. So we need to get this information, our Jumpstart team reviews it, and then we send that to our engineer so that they know what to do the calcs and design everything in our system towards. So just the last thing is the importance factor. Most of the projects we do, office buildings, even educational facilities, get an importance factor of 1, which just means it's basic. Anything above 1, 1.15, 1.5, like hospitals might be a 1.5. All that means is that our engineers need to apply a higher safety factor to the design. So there's more steel, there's more screws, the distance or the spacing between the anchors is less. Just trying to make those buildings, as bulletproof as possible. So in the event of, a natural disaster or something like that, you'd really want like the hospital to be like the one building that was definitely still standing, right? So that's why hospitals would get a higher importance factor, is to make sure that if they're still up in an emergency. So then 2 other things real quick and we'll wrap this up. Just wanted to go through live load deflection and what that is. So when we're talking about live load deflection, we're talking about how much vertical movement up and down that slab will experience. Also consider differential movement from floor to floor. So this is a old school sketch drawing, but it kind of shows the point. So this would be like a steel beam or a concrete floor. And then where it's at the column, it's pretty rigid. But then the span in between the columns, when you put your office desk or you roll a refrigerator or something, or even just a group of people going into a conference room, that floor is going to shake and move up and down. So if our curtain wall system's hanging on the floor, we need to be able to handle that amount of movement up and down. So this is our stack joint detail. And this is the head or the top of the unit, which is hanging on this floor. And then this piece of glass and this sill member is the bottom of the unit, which is hanging on the floor above. So this floor could be still, and this floor could be bouncing down. So we need to have gaps and clearance in our window system to be able to handle that amount of movement. So all of our systems are designed to handle 3/8 of live load deflection. You can make some modifications, just by notching something a little bit higher, or to create a little bit more clearance to handle a 1/2 inch of live load deflection. Once you get higher than that, like stuff gets crazy. Like we need to get the parts to be taller so that we can have bigger gaps, and there's usually more cost and schedule issues and things like that. So yeah, just make sure we know what we priced and how it was figured, and keep an eye on those numbers. And once you go over 3/8, you don't have a lot of wiggle room. So then last thing was wind load deflection. So wind load is a load that's imposed onto a structure by the wind or exterior elements. So deflection is the result. So the loads imposed cause the components to bend inwards. So on our window system, the glass acts as a giant sail catching the wind, and then most of the load gets transferred to our vertical mullions where our attachments are to the structure. But all elements experience wind load, whether that's a head, a horizontal, a sill, vert, jambs, glass panels, steel, etc. So over here, you got a piece of glass. So typically that's held in the frame at the top and bottom and or at the edges. So when the wind hits it, it's going to kind of bow and kink in. And then this is an example of a steel column. We have the C-beam program that our Jumpstart department uses that works with, same thing that AWS and Larson Engineering use to analyze how much deflection our vertical mullions are going to experience. And then there's limits in the code, in the design criteria on what's allowable, how much deflection is allowed. I think the glass can move up to an inch, but like you wouldn't want to be walking by a window and see the glass move in 2 or 3 inches. That would scare you or hit you and not be a good thing. So just then I had a fun little hand sketch trying to show that reaction. So here, this is like a 3-story curtain wall. So it's not going to go from the 4th floor all the way down. The deflection is going to occur in between our connections or our units, since each unit's got a connection at the floor line. So it's going to get the wind load's going to cause deflection on each individual unit like that. So that's it. I need to fill this out a little bit more and pile on some resources for future reference, but it's a pretty good one on the portal for engineering and the standard systems. They have, STC reports, mock-up test results, the sales catalog's really good when you're starting out trying to figure out what people are talking about and what parts go where. And that is it. Everyone still with me?
Yeah, that was really good, Brian.
Yeah, nice, a lot of content in there.
Thank you.
A lot of content.
It was really smooth too. The presentation was good.
Okay. So yeah, so again, it was hopefully primarily a refresher for all you guys, but we can get into more fun stuff on the next ones, hopefully. But it's kind of something that I've been doing with most of the new hires for a few years, and trying to get it down into 50 minutes was a lot, but there you go.
What's the
Does anyone have any?
What's the content for the next ones? Rough topics.
It should just be more like kind of piling on to the same stuff, just like more in depth, so we can get into like a little bit of waterproofing, NFRC testing, how to do, how to calculate the loads if you're in a design meeting for each anchor, what is dead load versus wind load, what slotted connections, and just stuff like that. But if any of you guys have specific requests, please feel free to pass them along. I think I got another month or 6 weeks or something before the next one. So if you have any ideas, please feel free to send them over.
Hey Brian, is this something that you actually do with new hires?
Yes.
Okay.
Yeah, he did it with me early on.
Yeah, normally I spend like 4 or 5 days where they're in and out of my office, and I kind of go through all this stuff with them, and it's a lot of hand sketches and looking at drawings, and then we have them do kind of a fake glass takeoff and size the glass and optimize metal and have them create a fake estimate and plug it in and do all that stuff.
Okay.
So, training. I remember that.
Yeah.
Yeah, especially the glass training. That's important in the beginning, like glass sizing and stuff like that.
Yeah, so like the next one might be like, how to size glass, how to optimize metal, things like that.
That's cool.
So yeah,
Good job.
cool.
Thanks, Brian.
Thanks, Brian.
Brian.
All right.
Thank you.
Thanks, guys.
Thank you,
All right,
Brian.
see ya.